You probably know what a maglev train is, or maybe you've had an MRI taken. But do you know what makes those work? Superconductors are what make both of those functional. So, what is a superconductor? Remember that a resistance is how much a certain object will restrict the flow of electrons, or current. A superconductor is a conductor that, when cooled below a critical temperature, has negligible resistance. But there's one more thing that defines a superconductor: the Meissner Effect. In theory, someone could create an ultra-pure crystal that has a resistance of 0 at some temperature, but if it doesn't exhibit the Meissner effect, it can't be considered a superconductor. The Meissner effect describes a superconductor's behavior in a magnetic field. There are two divisions of superconductor behavior, type 1 and type 2. Type 1 is a simpler one. When placed in a magnetic field, the superconductor will completely expunge that field up until some critical field strength above which the superconductor will be destroyed. Below the critical field strength, the magnetic field will not penetrate through the superconductor like it would a normal conductor. This is because of Lenz's law, which states that a conductor in a magnetic field will create an equal and opposite magnetic field by inducing a current. The superconductor does exactly this. It will produce a current around the surface, so instead of passing through the superconductor, the field will distort around it. Type 2 is a little different. Below one critical field strength, the superconductor will act the same as type 1 superconductors. But above this field strength and below another greater critical field strength, the superconductor becomes semi-permeable and moves into the vortex state. So what causes this shift? There's still a vortex at the surface, but deeper into the superconductor there becomes a lattice of smaller vortices, or eddy currents, which allows the field to pass through certain spots called flux tubes. As the field strength increases, these vortices will become closer together and eventually overlap at the second critical field strength, which causes a resistance and ultimately causes the superconductor to fail. While this difference between type 1 and type 2 may seem to be a minute distinction, it allows us to observe quantum mechanics on a macroscopic scale, and therefore is a remarkable leap in the understanding of condensed matter. Many thanks to all those who made this video possible.